In this video, we are going to take a look at note sorting. Now, first off, why would we want to apply note sorting to our notes?
Good question.
Well, at the moment, if we play around with edit mode enough, we'll find that there's currently a bug. If we are dropping notes onto the timeline, and we happen to drop some notes near the beginning of the song, and then try and play the new resulting song, we'll get a problem with the playback. Now, the easiest to show that by jumping in and demonstrating it. Let's say we go into song editor mode, we load up a familiar song, and now with our newly coded edit mode, we can go into note edit, advance a little bit in time, and drop a new note in place. So all that's been covered and works properly. Now what happens if we try to play the song at this point? Look at that, the song stopped on its own.
Because it registered that as being the last note, because it was the most recent one we put in.
Exactly. The way we're doing end of song detection is to look at the last note in the notes list and grab that note's tick value, and we'll call that the end of the song. What's nice about doing that is it's a very fast operation. We address the known number of a note, and we don't need a loop to do a lookup, so it's all very fast. The downside comes in when we begin to modify the notes list. Inside of edit mode, whenever we add a note to the list, of course that note ends up getting added at the end of the list. The problem comes in now when we do our end of song detection. We grab our newly added note, and that, in this case, that's that green symbol note. So that's reading as the last note in the list, and so our song end detection is saying, well, the song has ended because of that note's presence. So what we're going to do to correct this is we are going to add some code that will allow us to sort the notes list.
Okay.
And in so doing, if we sort all of our notes by tick, then the newly added note, we're still looking at the symbol note, would end up getting moved near the beginning of the list if we sorted all of the items. And then our end of song detection would again work properly by being able to use the real actual last note in the song.
Okay.
So let's see what we need to do to get this put together. Inside of our screen edit class, let's move down to our input section so we can take a look at our note creation. So down here into note edit mode, we have our note input handling, and it's here where we actually add the note. Now what we're needing to do is to turn around and tell song.notes to sort. Now we have some different overloads here, and we're interested in the second one. The second overload allows us to pass in a comparison delegate in order to handle the actual work of sorting, because we're in an interesting scenario here with sort. Now obviously the list's built-in sort method is going to have all of the actual sorting logic built into it, but that sorting logic isn't going to know what to do with a note, because a note is something we've coded. So exactly how do you know how to sort notes? In this case, it gives us the ability to write a delegate handler to handle the comparison for us. Basically what it's saying is, as long as we can tell sort how one item compares to another item of any given type, it can take that information and then perform the rest of the sorting functionality.
Okay.
So in this case, it's asking for a comparison, and it's asking it in the form of a comparison delegate. You'll notice that the comparison itself allows us to take in a type, and that's how we are allowed to specify our own type. Now that means before we can call upon this, we need to write just such a handler method. So temporarily I'm going to comment out the beginning of our sort, and let's find a good place to put some note sorting code. As a matter of fact, let's put that code directly into the note class. So over here inside of core, we're going to bring up our note class, and we'll jump in right below our constructor. Now what we're going to need to do is to create a method that satisfies the requirements of the comparison delegate. If we take a look at comparison very briefly here, if we were to just type out new comparison just to get an idea of how this delegate is working. So we've got comparison, we'll give it the type of note, and let's see, inside of here we're needing to specify, actually what I was looking for was the signature. Let me jump over to its definition. Here's what I was looking for. So we take in a specific type, and then what I was looking for was the parameters. So we can see here the comparison is asking for two parameters, a parameter called x and a parameter called y. You can see that we're returning an integer. So what's going on here is, well, if we tell it that we're passing in notes, what's going to happen is the comparison is going to require a method taking in two notes, a note X and a note Y.
Mm-hmm.
And then it's up to us to return a negative, 0, or positive value in order to indicate how these two notes compared. So let's close out our comparison definition, and let's write just such a method. And pull out our temporary delegate here, and let's write the actual handler necessary. We'll make a static method here inside of note. We'll make sure that this returns an integer, and we will call this method compare notes.
Now, do you need to specify this as public?
Not yet. We're going to go about that in an interesting way. If we were going to use this method directly, then yes, we would need to make it public. But the way we're going to set this up is in a way so that we do not repeatedly instantiate a delegate.
Okay.
I'll explain what that means here in just a minute.
Okay.
So, looking at the method now, in order to satisfy that method signature, we need to pass in two notes. And then just to match the naming scheme presented, we'll call this note X, and a second one we'll call note Y. So now the idea is that when this handler gets called via the delegate, it will pass into us two notes, and it's basically asking us which of these notes, X or Y, comes first.
Mm-hmm.
And we're going to compare these notes using their tick value, and if their tick value happens to be the same, then we'll drop into a comparison by track. Meaning if we had two notes that appeared at tick 0, but one was on track 0, one was on track 1, we'll say that the one on track 1 comes after.
Okay.
This is primarily for sorting out the saved data if we were to save the song out, because of course the song, two notes appearing on the same tick would be equal as far as we're concerned with our task of detecting the end of the song.
Right.
But we will employ both just to make sure that the output song format, if we were to save the file, would also be sorted. So what we need to do is to look at tick and see which of these two notes, X or Y, would come first. So let's begin with an if statement. We'll say that if note X dot tick is greater than note Y dot tick, then note X comes before note Y, and we will indicate that by returning a value of 1. So return a positive value saying, okay, this guy came before this guy, so therefore return 1.
Mm-hmm.
Now, if that wasn't the case, as a matter of fact, let me step back a minute. I'm also going to pull the braces out of this if statement just to make the code a little bit more compact. Now, if that wasn't the case, let's say tick Y came before tick X. So let's do an additional check and say maybe note X dot tick was less than note Y dot tick. If that's the case, we'll indicate that fact by returning -1. So that takes care of X coming before Y and Y coming before X. Now, what happens if they are both equal? Well, let's drop down an if statement and say if X dot tick is equal to Y dot tick, then we'll need to do what I'm going to term a subcomparison. So if the ticks were equal, maybe the tracks are different. So we can drop in here and say maybe note X dot track was greater than Y dot track. And if that's the case, then we'll indicate that X comes before Y by returning 1. And then we'll do the opposite. Matter of fact, to get slightly lazy, I'll copy this one if statement, duplicate it. We'll say that if X dot track was less than Y dot track, return -1.
And you can't ever have a situation where the tracks will be equal.
Actually, you can.
You can?
Well, you'll notice already
I guess if their ticks were different?
If both their tick and their track was the same.
Mm-hmm.
Now, granted, that's a case that shouldn't happen.
Yeah.
Because we've got a lot of code to make sure that in free play you can't hit a note on top of another note.
Right.
In edit mode, it toggles, so you can't have two notes on top. But still, it's if you let's say you modified one of the data files, you could put two notes directly on top of each other. And the method itself is not happy with the return scenario here because all of these returns are conditional. As far as the compiler is concerned, there's no guarantee that we're getting a return value.
Right.
And we need a return value to satisfy this integer return.
So you'll just return out 0.
Right, we'll set up kind of like a default catch-all by if none of those if statements were true, then we'll drop out entirely and return 0. And return 0 is a completely valid response from compare notes, or any comparison function. It's just saying that, okay, the two values we got in, they're equal. So leave them alone as they stand in the list. A way you could think about this is, imagine if you had a list of strings and you had the word cat appear multiple times. That's still a valid list of strings. That still has to be handled.
Right.
It's just all those values of cat end up needing to be grouped together at a certain point in the list.
Okay.
So returning 0 is indeed a valid response to the comparison. And in the case of our notes, if they happen to be equal on both tick and track, then we'll simply say that they're equal and return 0. All right, now that we've got our comparison in place, let's follow this out the way you were mentioning before. You're talking about making this public so we could see it back in Note. And that from the outset seems to make sense and will work, actually. Let's just temporarily, let's make this public. That means from the edit screen, when we're going to do our sort, we can drop in a new comparison delegate. So we'll do new comparison of type note. And to this comparison, we need to pass in a method that matches the given signature, return of integer, and takes in 2 note parameters.
Right.
Well, we have just written such a method over inside of note, which is note.compareNotes. So that would fit. That'll finish off our comparison and our sort. We can see at this point, we can build, and everything would work perfectly. Now, what I want to avoid here is the fact that this currently means every time we add a note, we call the sort, and we instantiate a new comparison delegate.
Gotcha. So you want to get that comparison delegate out of the way first.
Right. Since adding notes is something that will be done very frequently, we want to make this as efficient as possible. So what we're going to do is, instead of instantiating the delegate multiple times, we'll instantiate it once as a static field inside of note, and then simply reuse that field. So what that means is we could probably just cut that entire code. Actually, I'll retype it just to make it clear. So we know we can't do that. So instead, over here in Note, what we want to do is we want to make a static field. We'll make a static field of type comparison. Comparison of type note. And let's call this field note comparison. And let's turn around and immediately instantiate a new note comparison delegate. We need to pass in the method, so once again this will be compare notes. Now we do also want to make sure that we make this public. And then we can take our compare notes method and remove public. So we'll leave compare notes being a private static method of note. We'll make the note comparison look at that private method, but we'll make the comparison itself public.
Gotcha. So we can just look at the result of that.
Exactly. Now with this note comparison, we can go back over to our edit screen, and when we go to do our sort, we can pull all of this out and instead sort using the comparison found in note.noteComparison. So there is the delegate already instantiated, and we can simply use it multiple times without reinstantiating it. Alright, now it's time to test out our new sorting functionality. Let's jump back into the game and repeat our test where we were causing the song to end early. Let's go 1 quarter note into the song and drop down an additional symbol note. Now let's try playing the song and see how far it gets. So we heard the extra symbol play, but our song is continuing to play until the very end.
Nice.
So our sorting is indeed working, and we can continue to use our method of looking at the last note as our end of song detection.
Very cool.
So with that, that's really what we needed to cover in this video. Again, we were just looking at note sorting so that we can properly position our notes in the list as well as in time. And this is, of course, useful in the various places where we use the position to look at the beginning or end of a song. So with that, that's going to wrap up this video.